Hello my fellow humans, I'm Peter Bois. Welcome to my first ever electronics build video. We are building a trap for an elusive creature that has never been caught, the leprechaun. So I'm pretty pumped about this build today because we're just gonna put things together with some tape. It's not gonna look pretty, it's just gonna get the job done. So the links to all the materials you'll need are below, and my code for the Arduino Uno will be linked below. It'll be on my GitHub. So grab your jumper wires and let's get into it. All right, so we are building a Leprechaun Trap. And I really don't know how to spell leprechaun. I actually had to look that up. We are going to build a traditional box trap. You know, the one with the box, the stick, the string, and the acorn. The squirrel comes in, grabs the acorn, trips the stick, and closes it on top of it. But we're going to use a box, a stick, a servo right there to activate the stick and close the box. Then we need our bait, which will be a pot of gold, and we're going to put a ultrasonic sensor inside of there. So when the leprechaun sees the gold, it'll walk towards it, and we'll put a distance, I don't know, maybe we'll try 10 centimeters on the ultrasonic sensor, and when it senses movement, it will activate the servo and close the box on top of it. We are going to run everything off of an Arduino Uno, and that is going to be connected to power. We won't run this off a battery. So we need some materials. We're going to need the Arduino Uno. We're going to need a servo. We're going to need the ultrasonic sensor. I'm going to go find a stick in my backyard, find a box, and a pot for the pot of gold. And some gold coins, of course. You can't attract a leprechaun without a bunch of gold coins. And you need a leprechaun. Hopefully we'll catch one. We will find out at the end of the video. And we're not doing any soldering, so we're going to need jumper wires to connect everything together, and a small breadboard. Although I made a little audible on the small breadboard, so you might not need a small breadboard. And again, this is a no soldering project. All right, so we need our materials. We have the Uno, the breadboard, the wires, the pot of gold, the ultrasonic sensor, and the servo. First things first, we need to cut up our box and make it just the right size. I trimmed off a little bit. Now we need to cut out 2 holes out of the pot for the pot of gold so our ultrasonic sensors can poke through. The sensor has those 2 circles on it, and one is the trigger and one is the echo. It sends out an ultrasonic signal. It bounces off whatever's in front of it and sends it back, and it measures that distance, and with some math you can convert it to centimeters or inches. Then you can tell the Uno whenever it sees something within a certain distance to activate a trigger or a servo in this case. And there it goes, fits perfectly, and it looks like the pot has eyes now. All right, next up is our servo. Need to attach an arm to the servo. And time to start plugging things in. First, we need to attach the ground pin. Then comes the echo pin, and the echo pin goes into pin number 12 on the Uno. Then the trigger pin gets connected next. I didn't have enough of those jumper wires, so I had to create a little daisy chain of jumper wires here. And the trigger pin goes onto pin number 13 on the Arduino Uno. And then VCC, which is the power. It needs 5 volts to power the ultrasonic sensor. That goes to 5 volts. Now the Uno has 3 ground pins, so there are plenty of ground pins for our sensor and our servo, but it only has one 5-volt out, and the servo needs 5 volts and the sensor needs 5 volts. So there's a couple ways you can do this. One, you can connect the 5 volts from the Uno into a breadboard and then plug the VCCs of each of the sensor and the servo into the same row, and then that'll distribute 5 volts to each device. Or you can use a alligator clip with a pin on the other end. This is actually a little bit easier because then you don't have to attach another breadboard inside of the box. You'll just have a bunch of wires. So the alligator clip gets plugged into the 5 volts on the Uno, and then you can just clip the jumper wires of each device into the alligator clip. All right, time to hook up the servo. We have the brown wire is for ground. There's another ground pin available on the Uno. And then the red wire is for power, needs 5 volts. So we're going to connect that to the alligator clip. And the yellow wire is a control wire for the servo that needs to go into a PWM pin. So that'll go into pin number 10 on the Uno. Okay, so here is the sketch for our Leprechaun Trap. So we're using a servo, so we need to include the servo library. Then we need to create our object, and we're going to call the servo the_stick. Then we're going to create 2 variables for the 2 positions of the servo motor, one for ready and one for closed. Then we need to define all our pins, the trigger pin, echo pin, and the servo control pin. And we have a begin our serial port. Then tell the Arduino which pins we are using and if they're outputs or inputs. We have to tell the Arduino which pin we're using for the servo with the attach command. Then we're going to set the servo to the trap ready position, which is 180 degrees. This next part activates the ultrasonic sensor and measures distance of whatever's in front of it and converts it to centimeters. Here is our if statements. If the distance is over 200 or under 0 centimeters, then it'll print out of range in our serial port. But if the distance is less than 10 centimeters and greater than 1, so between 1 and 10 centimeters, it is going to move its servo arm to the trap closed variable, which is 90 degrees. And then our else statement, if the distance is not in these 2 parameters, it will just print the distance it is picking up off of the object in front of it. Okay, time to install everything in the box. Going to create a couple of holes for the USB port and the barrel jack. And a perfect fit. And like I said, this is a down and dirty project. We are just going to tape things in. We're not making this a permanent project. This is just for St. Patty's Day coming up. So I just taped it in using some gaffer's tape. Now, time to attach the stick that I found in my backyard to the servo arm. And again, I'm just using gaffer's tape, but you could use duct tape for any of this. Careful though, duct tape does leave a residue when you take it off. Gaffer's tape does not. And I have a lot of gaffer's tape around because I use it a lot for my shows. All right, the servo will be attached about there. And it only needs to last 1 day because St. Patty's Day is 1 day. All right, time to plug everything in. And we have a lot of wires and they're a mess, so I'm just going to use some masking tape to hold the wires down and keep them out of the way, and so they don't become unplugged while we operate this thing. And everything's plugged in. Install the ultrasonic sensor in the pot of gold. I think that's my favorite part, how well the sensor fits in that store-bought, Amazon-bought pot of gold. And we need gold for the pot, of course. How were we supposed to attract leprechauns without a pot of gold? I have a 9-volt power adapter as my power source. I realized I needed to cut a little bit more out next to the USB so I could have access to the reset switch on the Arduino Uno. That'll reset the code and put the stick and servo back in the ready position. There it goes. When you press that button, it resets the code and the stick goes back to ready position. I noticed my stick was too long. The box was just going to fall backwards, so I needed to trim a little bit off. The final length of the stick was about 6 inches long. And I press the reset switch on the Uno, and it resets the stick back to ready position. And it's not falling over. Time to test. Oh, it works. I think that's a win. We have our leprechaun catcher. Thank you all so much for watching the video. I hope you enjoyed it. If you liked it, please like the video below, hit the subscribe button, hit the notification bell, and I look forward to making more videos for your entertainment pleasure.